So in this video we're going to introduce a new structure in MATLAB called a repetition structure, or more commonly referred to as a loop. So let's start off by talking a little bit about why you should learn how to use loops. So pretty much so far everything that we've done in MATLAB you could do by hand if you had to. Right? You can perform mathematical operations, you're probably doing this in your math classes right now. You can create graphs, you can create conditional statements using your logical operators, and then you can use those logical operations to make decisions based on different input values or different sets of data that you have. Right? You could do all of this by hand. It might be a little bit easier to do it in MATLAB, but you wouldn't have to use MATLAB if you couldn't. So instead of the previous commands, what if I were to ask you to do the following? Basically perform a computation, let's say 10 times. Okay, you could probably do that same computation 10 times. It might get a little boring towards the end, but you could probably do that. Okay, what if I were to ask you to do the same computation 100 times, maybe using different input values and things like that on each different time that you perform the computation? Again, you could probably do that by hand. I'm sure you've all had math assignments where you've had, 10, 20, 50, 100 problems, and you did them all, right? It gets really boring by the end, and you probably start to curse my name under your breath when you get towards the end of those, but you could still probably do all those computations. What if instead I were to ask you to do that same computation 1,000,000 times? I don't think I know anybody who would want to sit there and perform the same computation 1,000,000 times, even if you're using different input values. What if I wanted to have you perform that computation? You get to select what input values you use for the equation or whatever it is that you're doing, but you have to keep doing it until you find the one combination that gives you the number that I'm looking for. Okay, you could be sitting there for the rest of your life performing that same computation, picking different input values, and you may still never find that value that I'm looking for. Okay, so this is why we want to learn about how to use loops, because with loops, as we'll see, we can repeat things, and the computer doesn't get bored. Right? It'll sit there all day, perform the same computation over and over, and it's never going to complain. Right, so we can see why it might be important to understand how to use a loop, but what exactly is it? So a loop is basically just a block of code that repeats itself. Okay, we're going to talk about loops here in MATLAB, but pretty much a loop is one of the most common structures that you have available in any programming language. So as we look at how we can use a loop, there are kind of two ways. One is that it can be programmed to repeat a fixed number of times, or it can be programmed to repeat until some event occurs. Okay, and we're going to actually have two different structures based on these two different situations. So when we talk about the fixed number of times that a loop will repeat, we call that a counter-based loop. The actual type of loop that we'll use in MATLAB is the for loop. And when we talk about that the loop is going to repeat until some event occurs, we call that a conditional-based loop because it's based on some condition. And the type of loop that we use in MATLAB is the while loop. Okay, so let's take a look at a comparison between these two types of loops so we can start to develop an idea of when we'll want to use them. So, as we saw before, a counter-based loop is going to run a predetermined number of times. However, the conditional-based loop is going to run until some condition occurs. Right? So we may not know how many times it's going to repeat. Okay? The counter-based loop uses what we would call a counter variable, right? Something that's going to count how many times the loop is repeated. For the conditional-based loop, you can pretty much use any variable as long as you can test its value. For a counter-based loop, that loop variable, or in this case the counter variable, gets updated automatically by the loop the way that it's set up. For the conditional loop, you have to have some statement somewhere within inside the body of the loop that updates the value of your variable. And really, if you think about both of these, they're both based on a condition. It's simply that for the counter-based loop, we know when that condition is going to occur that stops the loop from repeating, unless you make a mistake, and we'll talk about that in a little bit here. However, with the conditional-based loop, you don't know exactly when that event is going to occur that's going to cause the loop to exit. Okay, so that's the main difference we have between the counter-based and the conditional-based. For the counter-based, you know it's going to stop at a certain point. For the conditional-based, you know it's going to stop at some point, but you don't know when exactly that point will be. Here's another way to think about the two different types of loops. So pretty much any time that you need to use a loop, you can always use a conditional loop. Okay? The counter loop is basically a subset of the conditional loops, right? we can set up a condition to say, I want to repeat 5 times, right? That's a condition. The counter-based loop, or in our case the for loop in MATLAB, makes that a little bit easier to set up and to do than the conditional-based while loop. But you can always use a while loop or a conditional-based loop. You'll really only use the counter loop when you know that you want to repeat something a specific number of times. All right, so let's take a look at a couple situations and try to figure out which type of loop you would use. For each of these, if you want, after the problem statement is displayed, you could pause the video and try to think about which type of loop you would use if you were actually presented with this problem and you needed to pick. Okay, so our first situation. You want to calculate the position of a moving object based on its initial velocity, its angle, and the time since it was launched, stopping when the object comes to rest. Okay, so what can we tell about this situation? Okay, so we have an object moving. We know its initial velocity, its initial angle. We know how long it was since it was launched. We want to stop performing this computation, basically updating its position when the object comes to rest. Well, so we don't really know when it's going to come to rest. We know it will come to rest at some point. So for this situation, we would want to use a conditional loop because we don't know exactly that endpoint. Next situation. So you want to calculate the position of a moving object, again, based on its initial velocity, its angle, and its time since it was launched, but only for the first 5 seconds of its trajectory. In this case, it would be more appropriate to use a counter loop because we have a specific range of time that we want to perform this operation, basically calculating the position of the object. Right, so we can set up a counter-based loop to, say, repeat 100 times in those 5 seconds, something like that. So now you need to create a random set of 100 values to simulate the measurements for some machine that you're trying to develop to test the algorithm to see whether it works correctly. Okay, so for this situation, we would probably want to use a counter loop. Because we know we have 100 values that we need to create, we have a specific number of times that we need to repeat this process of creating a random variable, those 100 times. All right, another situation. So now we want to collect performance data on a new engine for 1 million revolutions, unless the measurements indicate that there's a problem, in which case we need to turn off the engine so we don't damage the engine and keep us from continuing on with our experiments. So, which type of loop would you use in this case? Well, you see that we have the million revolutions there, so you might initially think that we would want to use a counter-based loop. However, we have that second part of the statement that says unless the measurements indicate there's a problem. So for this case, we'd actually have a conditional loop with 2 conditions. The first condition is basically a counter condition, so once we reach a million revolutions, then we stop. But we would also need to have a second condition where it stops the code from running or the experiment from running if the measurement indicates that there's a problem. So we would need 2 conditions. In that case, you would need to use a conditional loop. And last example, so now you need to ask the user of your program to enter a number, and you want to check to make sure that the user enters the value within a specific range. You can't let the program continue until the user enters an appropriate value. So which type of loop would you use here? In this case, you would want to use the conditional loop again because you don't know how long it's going to take the user to be able to enter an appropriate value. Hopefully they enter their value correctly on the first time and you can just continue on with your program, but you may end up with someone who has no idea what they're doing and they just completely enter in random values and you just have to sit there and continue to repeat asking the user to enter the value until they enter it correctly. So you'd want to have a conditional loop here. So finally, let's talk about some items that we should know about loops in general. So first is that the condition for the loop is only checked once during each iteration. That's basically at the beginning of each iteration. So that holds for if you're using a conditional loop, it checks that condition. If you're using a counter-based loop, it checks the counter only at once during the iteration and at the beginning. Right? The conditional test that we set up for a loop is based on what we call the loop control variable or loop control variables. Okay? So those variables need to be initialized prior to entering the loop, otherwise you don't know what your initial value is and you might completely skip over your loop. Right, they need to be updated somewhere within the loop, and when the loop control variable takes on a value which causes that condition to fail, the loop is going to stop and continue on with the rest of your program. Like I mentioned before, the for loop or the counter-based loop actually takes care of most of this for you. If you use the conditional-based loop or the while loop, you're going to have to actually make sure that you take care of all these steps. The code that is repeated, we usually refer to it as the loop body. And every time the loop repeats, we call that an iteration. So from now on, we're going to be talking a lot about iterations, right? So just realize that the iteration refers to the number of times that the loop has repeated. So that brings us to the end of this video. Hopefully you now have at least a little bit of idea of what loops are and why you might want to learn how to use them. And the other videos associated with this one, you'll be learning more specifically about the for loop and the while loop.